When database records become too complex for a standard spreadsheet, the logic of the system needs to change. MongoDB handles this by storing information in a document format, grouping related fields within a single flexible record. We are going to build a functional school database from scratch, designed to store and manage student profiles. To follow along with these steps, you will need MongoDB and the Mongo shell installed and active on your system. By applying these terminal commands, you can organize a stream of raw information into a structured, searchable database environment. Step 1. Initialize the environment. Type use followed by your database name, school. The terminal confirms you have switched context. Now we need a container. Run db.createCollection and pass in students. The terminal returns OK1, indicating it's ready. However, if you run the show DBs command to list your databases right now, your new school database will not appear in the results. This occurs because MongoDB requires an actual document to be inserted into a collection before the database structure is permanently saved to the system. The commands we've used so far create the framework, but the database isn't fully recognized until it holds real data. Let's populate that framework. To add a single record, type db.students.insert1. Inside the parentheses, use a set of curly braces to map out your field value pairs, like a name of SpongeBob, an age of 30, and a GPA of 3.2. Note the spelling of insert1. MongoDB uses camel case formatting, so capitalizing the O is necessary for the shell to recognize the command. Hit Enter, and the terminal returns acknowledged true, alongside a unique object ID. This ID acts as a primary key, confirming your data is written. To add multiple students at once, use Insert Many. Place all your document objects inside an array, defined by square brackets. Each record gets its own curly braces. Separate these blocks with commas, so the shell distinguishes where one profile ends and the next begins. Maintaining this precise placement of brackets and commas ensures the shell correctly interprets your data as distinct objects, rather than a single broken command. Now that we have a collection, we can retrieve the records. Running db.students.find with empty parentheses lists every document we have inserted so far. As a collection grows, viewing everything at once becomes inefficient. To isolate specific records, you pass a query filter into that find command. If we place search criteria inside curly braces, like the name field set to SpongeBob, the shell returns only that specific matching document. You can apply this to any field. Filtering for a GPA of 4.0 will return only the student profiles that share that exact value. These query filters allow you to treat a large repository of data as a precise tool for gathering specific information. Managing a database involves removing records. To drop an individual file, use db.students.delete1 and target a specific field, like a name. The shell returns a deleted count of 1. Running a find command immediately after shows the targeted profile is removed. For mass removals, the delete many command can target multiple documents based on shared characteristics. For example, if we need to remove files missing our registration date, we use the exists operator set to false. This targets every document where that specific field is absent. Before running a mass delete, execute a find command using the same criteria. This allows you to verify exactly which records are about to be removed before you commit to the deletion. Data removal requires precision. Using retrieval commands to check your filters ensures you only clear out the data you intended to remove. By following these steps, you have successfully built, populated, queried, and managed a new MongoDB collection. These operations form the foundation of CRUD, the ability to create, read, update, and delete data within a database environment. From here, the next step is learning to modify existing data in place using update operators, allowing you to refine records without removing them. Database management is a logical, methodical process. By understanding these core terminal commands, you can maintain clear and accessible data structures for any project.